Hey guys, as you can see, we're a little under the weather, but we're still going to do this. So today we're doing right angle trigonometry. So our essential question is, how do I use sine, cosine, and tangent functions? And so those are the sine, cosine, and tangent buttons on your calculator.
Right. So a trigonometric function is a function whose rule is given by a trigonometric ratio, a fraction. A trigonometric ratio compares the lengths of two sides of a right triangle. And notice it says right triangle. That's very important. The Greek letter theta is traditionally used to represent the measure of an acute angle in a right triangle. The values of trigonometric ratios depend upon theta. So if we look at this picture right here, they talk about how they find sine, cosine, tangent. And another name for it, sine it's so, ca, toa. So sine, if it's always, you're always looking at your theta in order to determine.
That's our hey look at me angle, remember? Hey, look at me from geometry.
There we go. So means opposite over hypotenuse, and that's where they got 4/5. Hypotenuse is always the side opposite the right angle.
Yes.
Ca is cosine, which means adjacent. So the adjacent side to theta, which is 3 over the hypotenuse, which is 5.
And across from it is always opposite, sorry.
Yep.
There we go.
And tangent is going to be toa, which is opposite over adjacent, 4/3.
4/3. Got it.
And so we'll always have you label what's opposite, what's hypotenuse,
So
what's
find your hey
adjacent.
look at me angle. One across is always opposite, across from 90 is hypotenuse, so left over one is adjacent.
Exactly.
Great.
Okay. And the triangle shown at the right is similar to the one in the table because their corresponding angles are congruent. And so therefore, notice the sign is the same.
Right. So since we know that we have a 90, we have the theta, which is the same. We always know by the third angle theorem that the third one's the same. So if all the angles are congruent, then the corresponding sides will be as well.
Correct. The values of the sine and other trigonometric functions depend only on angle theta and not on the size of the triangle.
Correct. So as you see, this triangle's bigger, this triangle's smaller, but they're still the same.
Same sign. Yep, exactly.
Okay.
Okay. On the next page, which I will go to right now, we are going to do an example.
Yeah.
So we're going to find sine, cosine, and tangent.
So here's our hey look at me angle. Right away I'm going to label opposite. Hypotenuse is always across the 90, and the last one's always adjacent. And off to the side I'm going to write my SOHCAHTOA so that I remember what fractions I can write.
Perfect.
All right, so this one says sine, which is opposite over hypotenuse. So we have sine of theta equals our opposite, which is 30, over our hypotenuse, which is 34. And that reduces to
15/17.
Great.
Perfect. Do you want to circle that?
Sure.
Cosine.
Cosine's adjacent over hypotenuse. So we have cosine of theta is adjacent to 16 over hypotenuse, which is 34.
Exactly.
That reduces to
8/17.
Great. So really you're just plugging in the numbers for each spot.
And tangent.
Opposite over adjacent. So we have tan of theta is our opposite number is 30. Or our adjacent is 16, and that reduces to
15/8.
Great. Don't change it to a mixed fraction, just leave it improper.
Yes, exactly.
All right.
All right. So now we're going to talk about two special right triangles, the 45/45/90 and the 30/60/90. So if you have a 45/45/90 triangle, the length of the hypotenuse is going to be √2 times the length of a leg. So in a 45/45/90 triangle, each of the legs are identical.
Right.
And so therefore the hypotenuse is just x times √2. X is the length of a leg.
So in geometry, we call that L, L, L √2.
Perfect. In a 30/60/90, the length of the hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg is √3 times the length of the shorter leg.
Right. So in geometry, we called across from the 30 the S, across
Okay.
from the 90 was 2S, and
Okay,
across from the 60 was S√3.
perfect. Okay,
Same.
yeah, all right. So here, we have example
So we have a
number
45, 45.
2. Yep, exactly. There we go. Mm-hmm.
You can label your sides. I'm going to label mine L√2.
Mm-hmm.
Or you could label them X, X√2, whatever works
Right,
for you.
doesn't matter. But now we know that 20 is equal to L√2.
Right.
So we're going to
So
set
let's
them
write
equal
that
to each other.
equation. L√2 equals 20.
Right.
Now we just solve for L.
So we divide both
Divide
sides
by
by,
√2.
yep,
We do not like roots in our denominator.
no.
So right now we have L 20 over √2.
Mm-hmm.
Remember, to get rid of the root, we multiply by √2 over √2. Whatever's in the denominator, you multiply that.
Exactly.
So then, do you want me to do it all the way out, or just know that those cancel and give us 2? It's up to you
Well,
guys.
20, let's write 20 √2
Yep.
over 2.
Yeah.
Is that what you mean?
That's what I was asking.
Oh.
So √2 times √2 is really √4.
Mm.
Oops. Which the square root of 4
Is 2. Exactly.
Okay.
And
Now
now
we can simplify. 20 divided by 2
is
just
10.
gives us 10.
So 10 √2 is equal to x, and that's what it's asking us to find.
Yeah.
Our x.
So this side is L√2. Oh, no, I lied. That's not L√2. This is our L√2 side. So 10 √2 is our answer for x,
Mm-hmm.
which means that this side is 10 √2
Mm-hmm.
and this side is 10 √2.
Exactly.
Great.
All right. And that's also can be called, like Miss
Or
Boyd
X.
called it L
Or
or X. It
whatever
doesn't matter.
letter you want to call it.
All right. Should we try this one?
Sure. So crossing 30 is our X or S, whatever you want to call it.
Mhm.
Here's our S2 or
Mm-hmm.
2X, whatever you want to call it.
Mm-hmm.
And this one's S√3.
Mm-hmm.
So this time we know this one.
Right.
74.
Right.
So that's our equation we're writing. 2S equals 74.
Right.
Oh, this is easy.
Yeah.
Just divide by 2.
Mm-hmm.
So S equals 37?
Yeah.
Great.
Done.
So this side is 37.
Mm-hmm.
And do we have to plug it in for all of them, or we're just finding X?
Mm-mm.
Oh,
Just
that's
finding-
nice.
yeah.
This is way easier than geometry.
Just finding the value of
All
x.
right.
That's it.
Great.
Does that make sense? Are we
Mhm.
good? Okay. So, let's see. Make sure that your graphing calculator is set to interpret angle values as degrees.
Mhm.
So we'll go over this in class, but you want to press mode, check that the degree and not radian is highlighted in the 3rd row when you press mode. That's
And we'll check it for you. in class.
pretty easy. You can do that, but just we'll double check it for you. Okay.
Great.
Next page. We have another example here.
All right.
A skateboard ramp will have a height of 12 inches, and the angle between the ramp and the ground will be 17 degrees. To the nearest inch, what will be the length L, that's an L,
Mhm.
of the ramp?
All right. Well, we don't have any 30, 60, 90, or 45, 45,
No.
90s. But we do have a 90 degree, so we
And-
can use SOHCAHTOA.
And we have a theta.
Yeah, here's our hey, look at me angle.
Mm-hmm,
So across from this is our opposite,
mm-hmm,
across from this is our hypotenuse,
mm-hmm.
and our adjacent.
Perfect.
Now, which one doesn't have anything on the side? Well, we're not going to use adjacent. So we're
Exactly.
going to use OH, which is so sine,
Yep, so
So the
sine
sine of
17
17
degrees.
equals our
Plus-
opposite, 12, over our adjacent, L.
Mm-hmm, exactly.
Now we have to solve.
Right. Do I put a little degree on that 17?
Sure.
Yeah. So now we're going to solve. So we multiply both sides by L.
Yep. Those cancel.
Yep. So we
we're
get
left with
L sine,
sine of
17 degrees.
I'm just going to put it in parentheses.
okay, equals
12.
12.
Now we want to get L by itself.
So we're
we
going to divide both sides by
all of
sine 17.
And this is when you plug it in your calculator.
Mhm.
So L equals, when you
And
plug it in,
You
get
take 12 divided by sine 17. That's why we said to change that on your
Mhm.
calculator. When you do that, you get, and I'm going to tell you the number you get. You actually get 12 over, so if they want to check it, 0.2924, which is equal to 41 inches. Done.
Got it. So you don't have to do these separately. Just plug in your
No.
calculator 12 divided
Right.
by sine
We're-
17 and
Yep,
you'll get
yep,
41.
yep.
Okay,
All right.
great.
When an object is above or below another object, you can find distances indirectly by using the angle of elevation or the angle of depression between the objects.
Great. But remember, for angle of depression, you have to start with a horizontal and then look down. And for angle of elevation, you have to start with a horizontal and then look up. So you may have to find the angle of depression if it's not a horizontal line.
Perfect. So should we try this one?
Sure.
All right. A surveyor whose eye level is 6 feet above the ground measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.7 degrees.
So here's our roller coaster. Sorry, the surveyor whose eye level is 16 above ground.
6.
Oh, 6, sorry. So here he is.
So
He's already 6 feet up.
Yeah.
Got it? Okay.
If the surveyor is standing 120 feet from the hill's base, what is the height of the hill to the nearest foot?
So this would be 120. And we're trying to find this right here. Okay. And it also said that the angle of elevation, so from a horizontal up, is 60.7.
Yep. And what we're actually trying to find is, we have to find what x is, but then we're going to have to add
Add it
6
to the
feet,
6,
right?
because we
Because
have extra.
we want to know the actual height of the hill.
Got it.
The height of the hill is from the bottom of the guy
Yeah.
all the way up to the top, okay?
Okay,
So let's
here's our
find
halo
x
look at me.
first.
We got opposite. Here's where our 90 would be. So hypotenuse, adjacent. We are not using the hypotenuse because there's nothing on it. So we're going to use O over A, which is TOA, tan. So we're going to do tan. We know the angle, 60.7, equals opposite, which is x over adjacent 120. Ooh, this is the nice one. Just multiply both sides by 120.
Right.
So in your calculator, please do that.
Can I move it down
Sure.
up a little?
So we get x equals, when you plug this all in your calculator,
You get 214.
great. So this is 214, but we want the total height. So we got to add on this extra 6.
Right.
So 214 plus 6 gives us 220.
And that is in
In
feet.
Great.
That is the height. That's what asking the height of the hill, the nearest foot.
Great.
Okay? All right. Reciprocals. The reciprocals of sine, cosine, and tangent are cosecant, secant, and cotangent. Those are the reciprocals of those.
Okay.
So reciprocal just means
Flip it.
flip it.
Flip the fraction.
So the reciprocal of, so cosine, so we should label which one goes with which.
Yeah. Great. So
Okay.
this one's sine. This one's cosine.
Yep,
This one's tangent.
yep. Exactly.
Okay.
And so
So
basically,
here's our hey, look at me.
right,
We got opposite, hypotenuse, adjacent for normal, but now we're going to flip them. So if we do the sine of this, it would be opposite over hypotenuse, which is 4 over 5. So sine would be 4 over 5. But then
cosecant
cosecant, we just flip the fraction,
is
which
5
is
over
5
4.
over 4.
Yep, that's all we're
Okay.
doing.
Great, that's easy
That's
enough.
pretty straightforward. Oopsie. On the next page, okay, so I just want to see what we all have here.
Yeah.
Okay, find the value of sine, cosine, tangent. Okay, then that's pretty easy. So I'm wondering if we should just
Let's skip
save
this
this
one.
one and do this one in class. And so the video questions is right here. Oh, sorry,
far.
go back. Is right here. And we'll
I'm gonna
scroll,
move
yep.
this.
So find the
Oh,
value of sine, cosine, and tangent functions for that triangle. And then what we're gonna do is we're gonna have to scroll, see,
Yep, there
and
we go.
yeah,
Now you can
I
see 'em all.
do our best. But this part B, it says tangent of theta is 2 root 5 over 5. Okay, that's the best I could do to
Yep.
get it all in.
It works.
But I think you can all see that. You can go back and forth if you need to. There it is again. What is your favorite summer activity? There's the triangle you're using, by the way.
Right.
And there you go. All
All
right?
right. See you
See you tomorrow.
I like stopped before we stopped.